So the very first proof technique that we are going to talk about are direct proofs. And recall that in this course we have a couple of different textbooks, so this content and related content can be found in the Book of Proof. Take a look at your syllabus to access that in section 4.3. So, how does a direct proof proceed? Well, here's our definition. So direct proof of a certain claim, so here the claim is P implies Q, and it's a proof technique. So it's going to take a certain form, and that form is going to be as follows. So here we go, that's our definition. We assume P is true, we make some sort of argument using logic or math or English statements, and then that allows us to conclude that Q is true. So right here we have a hypothesis. You assume that P is true. We have our argument showing that Q is true, and that allows us to claim our conclusion. So if you hear me refer to hypothesis, argument, or conclusion, I'm referring to these three parts of a proof technique. And this definition right here might look a little bit confusing. So let's go ahead and go back and show how and why does this thing work. So remember that I said that we're going to be relying on all the material beforehand about logic. So let's go ahead and revisit P implies Q to show why this is a perfectly valid kind of proof technique to show the validity of an argument or a proof of the claim P implies Q. So you might recall the truth table for P implies Q. So our truth table for P implies Q, we had the only time that it was false is when the hypothesis is true and the conclusion is false. And it is true otherwise. So if we are trying to show that P implies Q is a true statement, let's think about this. Well, if we want to show that it's a true statement, we don't really ever have to consider the case where P is false, because if P is false, that automatically means this is a true statement. So we don't even need to consider these right here. And so the only thing that we have to do is really concentrate on these couple of rows of our truth table, the very first two. And those first two is when P is true. So that's why this proof technique, the very first thing that you do is you assume that P is true. Because you already know that if P is false, your claim is already true, so you don't care about that. So you assume P is true. Great, so we're in these two cases right here. So what the argument does is it strives to show that this second row is never the case, but rather this row right here is the case. You want to show that this first row right here happens and that second row right there does not happen. So how are we going to do that? Well, you have to make some sort of argument that shows us that we're in this first row right here. Well, we've already assumed that P is true, so we know that we're in one of these two cases. So all that we need to do to show that we're in the first row is show that Q is true. So that's why in this direct proof, the conclusion right here is trying to show that Q is true. You make an argument to show that Q is true. Because if you're able to do that, then what you have established effectively is that we are indeed in this case right here. We're in that case at the very end of this statement right here. So this is a direct proof technique. You assume P is true, so you only concentrate on those first two rows of our truth table column. You make an argument that shows that Q is true, and then that shows us that we are in the first row of this truth table. And then you notice, conveniently, P implies Q is then a true statement. So this really is a proof of the claim P implies Q. So if you follow this structure right here, at the end of the day, because of this truth table, you will be able to verify that P implies Q indeed is a true statement. So if you argue in this sort of format, you will have developed a proof, a valid argument that shows that P implies Q is true. And don't worry, we will see lots of examples of this in action. So you might ask yourself, why would you want to have direct proofs as a proof technique in your toolkit? Well, it turns out the power behind a direct proof is this hypothesis right here. Assuming P is true. Because if you assume P is true, what that means is that you can actually use it in your argument. And that's why it's such a powerful proof technique, because it allows you to assume that P is true, and then you can use it in your argument to show that Q is true. And that's the power behind a direct proof.